Now we come to accuracy, precision, and significance of digits. We were discussing dimensions and units, but then when we are talking about units, we need to also consider that when we are measuring something, then we need accuracy, precision, and that kind of things in our scientific workout, in our scientific calculation, for the things, for applications to work in a way that we want them to work. And for that, accuracy, precision is so important. And therefore, when we are talking about dimension, units, and measurements, then we need to know what do we call accurate, what do we call precise. If we have to take approximation, what do we call approximate, and how good it is to justify it. So these things similarly. So in a unit, if something goes length or some other measurement, if it has decimals attached to it, then how many decimals we need to talk about? How many decimals? Where do we stop? After 5 decimals, 3 decimals, or 1 decimal, or what? What is called accurate for us? So on case-to-case basis, it differs, but then we need to consider and we need to take a uniform decision about it in our calculations and in the values that we are talking. This is a very important affair. This is a very important thing for consideration in scientific working and in development of machines, vehicles, anything that where precision and accuracy is involved, we need this. I give you an example, 1 or 2 examples where these things are important and where they played such an important role that a wrong approximation caused a lot of disaster. For example, in early 90s, if I remember correctly, a French rocket, Ariane, was launched into space, and I think $5 billion or more were spent on its development at the time. As it were, 7 seconds into the space, the rocket blew up and everything was blown, and the rocket ran into pieces, and I think the astronauts that were going in it, they died. So there was casualties, loss of life, as well as there was loss of all the money that was involved, that was spent on that, the time that was also used to develop it, and so on. So an inquiry was launched. The inquiry report is available even at net and other places. And it turned out that what was the error? The error was simply a false approximation, that instead of 24 digits, the approximation was concluded at 18 digits or something like that. So because 6 other digits were considered as insignificant and they were ignored, but that resulted in huge loss, monetary as well as life. Another example, in Iraq war, when Iraq attacked Kuwait or some other Arabian countries, again that was in 90s, one of the rockets could not be blocked, and it fired into the American defense. I think they were called as Parrot missiles. When it was flown to stop the Scud missile, it could not stop. What was the result? I think quite a large number of American army people, they lost their life, and it was a disaster again. What was the problem? That in development of that anti-missile, the chip that was placed in it, its calculation were wrong, and instead of again taking it 36 decimal points, they concluded, I think at a number, if I remember correctly, it was 16 or something like that. But what is the difference? But the point that I'm trying to make is that if the precision and these numbers, the accuracy, the decimals, if they are calculated accurately, then it results in that much better appliances, and they will deliver the results. If we cannot do that, if we ignore something, then we are likely to run into any kind of problem, as I have given one or two examples, but there are a large number of such examples that are available. Therefore, accuracy and error, to reduce error is important, and to make accurate calculations is important. However, for general daily life purpose, things are not as difficult as that, and we can manage with much easier situation. The value of one reading minus the true value is called the accuracy. But closeness of the average reading to the true value is important, and we want to reduce that gap. The real value and one reading, the difference should be reduced to, let's say, theoretically or ideally 0, to remove any error. But if the difference has some value, then that is reflecting the inaccuracy or the error in experimental results and theoretical values. One of the value of one reading minus the average readings is precision error. So there is a general error, then there is a precision error. Then this is a measure of fineness of resolution and repeatability of the instrument. The more accurate, the more precise the measurement, the less the precision error, the better will be our results. And generally associated, these are the things that are generally associated with random errors. Significant digits that are relevant and significant, and they are meaningful also. Let's say if we go to 10 or 20 decimal points, they may be of no use, they may be of no significance. So we have to decide, or we have to have a cutoff point where we need to stop after decimals. And all this that we are talking about is in scientific terms, not in generality. And where precision and accuracy is important. When performing calculations, the final result is only as precise as the least precise parameter in the problem. When the number of significant digits is unknown, the accepted standard is 3. If we don't know how many significant digits or how many digits we need to consider after the decimal point, then normally we take 3 digits into consideration. The dimensional homogeneity is a valuable tool in checking for the errors. We need to make sure that every term in an equation have the same units. We are talking about example of the accuracy and of course the difference between accuracy and precision. A shooter, for example, is more precise in picture A but less accurate. You can see the marks up there. In picture A, he is precise in the sense that he is within the two circles, so therefore he is shooting okay. But when we call to precision, how precise he is, I don't think he is very, very precise. Away from the body, you can see there are a number of marks there. While the shooter B is more accurate, he is targeting at the desired places, the desired points that have been assigned to him, but he is less precise. Because in this case, as you can see, that he is crossing the circle. So therefore, precision is not there.